Hello guys and welcome. So first of all, a small caveat: if you don't know any of the tools or maybe theory I'm going to be using, well then check out my YouTube channel, because there I give full lectures on every single theorem and every single tool that I use in my videos. And right now, ladies and gentlemen, we are supposed to find all functions that map the rational numbers to the rational numbers such that they satisfy the following functional equation: f of 2 times f of x plus f of y is equal to 2 times x plus a y for all x's and y's that are in the rational numbers, so the domain of the problem. And so this is actually a problem from, I think it is, from Canada, from Canadian Mathematical Olympiad from 2012. Whoa, I almost killed the board, yeah? I hope it's correct, so whatever. How are we supposed to get about this problem right there? So, you know what, first of all, let's maybe think about the basic function that would satisfy this functional equation. Well, for sure, the f of x equal to x will work here. I mean, here we're gonna get just, 2 times x plus y on the left-hand side, and that's exactly the right-hand side. So I think we should be expecting something of the form of the linear function. Yeah, we should, yeah, okay, lovely. So, for the first part, I would like to make some really basic substitutions. So for example, maybe let's try and substitute in x equal to 0 and y equal to 0 at the same time. So what we're gonna get is f of 2 times f of 0 plus f of 0, so f of 3 times f of 0 is equal to 3 times 0, which is 0. So f of 3 times 0 is equal to 0. Well, that's absolutely perfect, because now we know for which value of x is equal to 0, and that's for x equal to 3 times f of 0. Whew. But now speed, yeah, so what? I'm not on speed, I'm speed. Whatever, so for the second substitution, I would like to use the fact we just got and, substitute for both of the variables given the problem statement, so x and y, f of 3 times f of 0, such that those f of x's and f of y's here inside of this function will disappear and will just become 0. So hopefully we will get the value for f of 0 somewhere in the future. I would really, really love this. So what are we gonna get from this substitution? Well, we're gonna get f of 2 times f of 2 times f of what? 3 times f of 0. Yeah? And then plus f of 3 times f of 0. Yeah, and that's actually going to be equal to, well, this 0 is 0, so that's just f of 0, and it's equal to 6 f of 0 is 6 times f of 0 plus f of 3 times f of 0, so that's 9 f of 0, so f of 0 is equal to 9 times f of 0. Well, that means for sure that f of 0 will be equal to 0, and I would like to actually bring on the beautiful table of facts I used to write. So, facts, and the first fact is going to be that, well, f of 0, we arrived at the conclusion that is equal to a 0. Perfect. Yes, so let me erase this stuff from here to get a little bit more space to do some real math. So I'm just gonna write here that we got f of 0 equal to 0 from here. So now let's use this f of 0 equal to 0. Well, it's always nice to use stuff like this to maybe eliminate some terms. Which terms do I want to eliminate from this original equation? Well, those 2 times x times 2 times f of x, I don't like those because those are multiplied by something. I don't like stuff that is multiplied by something. I really want to get rid of that. So let me make a third substitution of x equal to 0, and let y remain, 0. I would like y to remain fixed right there. So we're gonna get this f of y on the left hand side, f of y equal to y. Well, that's absolutely perfect, because well, this means that f is its own inverse, and well, if f is its own inverse, well, it has to have an inverse in the first place, and if it has an inverse in the first place, well then, well, guys, it is a bijective function, which is absolutely perfect. Let me write it down in this table of facts right here. So f of x is equal to x. Lovely. So let's move forward. Where did I put my chalk? Here, probably. Yeah, lovely. So we know that f of x is a bijective function. So, well, I would like to once again use this fact that I just arrived at. You see, I would like to apply this function to both sides of this equation towards achieving a beautiful state where this f of x from this hand side just disappears in the process, and I have f of 2 times x plus y on the right hand side, and I can absolutely do it. I can just, for let's say the fourth step, and that's a nice font for a broken chalk, yeah, and I will get f of f of 2 times f of x plus f of y is equal to f of 2 times x plus y. I just applied function to both sides of this original equation, and so I can just drop those f of x's from here because, well, f is its own inverse, getting 2 times f of x is equal to, plus, and f of y is equal to f of 2 times x plus a y, which is absolutely perfect because, well, right now, guys, it starts to look like a Cauchy functional equation. I mean, it really does. And so what I would like to really get here, I would absolutely love to get rid of this 2 from here and maybe, you know, get this 2 from in front of this f of x into the f of x itself. So this becomes f of 2 times x, and I could really just, you know, say it's a Cauchy functional equation. So let's try and do it. But, well, the nice thing is that if I now make under substitution, let's call it substitution number 5, and I will remain, x will remain fixed by this substitution, and y will be equal to 0. What I'm going to get is, well, here I'm going to get just 2 times f of x. F of 0 is 0 by what we derived earlier, and that's going to be equal to f of 2 times x plus 0, so just f of 2 times x. That's absolutely perfect because that's exactly what we wanted here. Yeah, and so we can just use this thing right there. Yeah, I mean, we can let's connect those arrows somehow. So using those two facts right there, we can just combine those two, getting f of 2 times x plus f of that y is equal to f of 2 times x plus y. And so now, I don't know, let's maybe take some kind of an r, yeah, an r, and I will set r to be equal to 2 times x, and then we will get that f of r plus f of y will be equal to f of r plus y. And wait, ladies and gentlemen, this is exactly the Cauchy functional equation. And so what we get from here by the Cauchy functional equation, maybe Cauchy functional equation, equation CFE, we will get that f of x will be a constant times an x. Yeah, but that constant in question will be a 1 because, well, if it was anywhere, anything that is not a 1, well, then it just wouldn't really fit into the original equation. So I will just erase this constant from here, and so what we get is that the only solution to this equation is f of x equal to x. Let me use the fancy chalk. Yo. Now I feel awesome. I hope you guys liked it. I will see you in the next one.